Welcome to ISC Class 12 Maths tutorial. The topic is differentiation. In this video, I'm going to teach you how to differentiate inverse trigonometric functions. पहले एक शायर की दो लाइन सुने. शायर कहता है, ठोकरें खाइए, ठोकरें खाइए, पत्थर भी उठाते चलिए, ठोकरें खाइए, पत्थर भी उठाते चलिए, आने वालों के लिए राह बनाते चलिए, आने वालों के लिए राह बनाते चलिए. कल तो आएगा मगर आज ना आएगा कभी, कल तो आएगा मगर आज ना आएगा कभी, ख्वाब गफलत में जो हैं उनको जगाते चलिए, ख्वाब गफलत में जो हैं उनको जगाते चलिए. ख्वाब गफलत बेपरवाही, बेखबरी, लाइल्मी, अनभिज्ञता, इग्नोरेंस. थैंक यू. The first question is differentiate sine inverse 3x with respect to x. This is the question. I repeat the question. Differentiate sine inverse 3x with respect to x. This is the question. First question. I start like this. Let y is equal to. So let y is equal to. Write down. Let y is equal to. Let y is equal to sine inverse 3x. This is the question, sine inverse 3x. We have to differentiate with respect to x. And now we are starting like this. Let y is equal to sine inverse 3x. Therefore dy upon dx. Therefore dy upon dx. Therefore dy upon dx is equal to d dx of sine inverse 3x. Sine inverse 3x. Only I have written d dx, the operator on both the sides. I have done nothing else. Y sine inverse 3x as it is. Only I have written d dx this side also and this side also. Alright. I am writing all these steps so that you understand easily. Fine. Now, you know the formula d dx of sine inverse x is equal to 1 upon root 1 minus x square. Fine. But here you see, in case of x, we have this total we consider as x, this total. Sine inverse this total we consider as x. This is not x, 3x, but we imagine this is x. So d dx of sine inverse x is equal to 1 upon root 1 minus x square. X means 3x square, 3x whole square. And because it is not x, we are imagining, we are supposing this is x. So once again we differentiate this 3x, d dx of 3x. Because it is not x, it is 3x. Fine. Alright. So we can write down then this is equal to d dx of sine inverse x formula 1 upon root 1 minus x, but our x is, in place of x we have 3x. Alright, so 3x. And of course there should be a bracket. Sine inverse x is equal to 1 upon root 1 minus x square. Alright, this one let me write down in the middle. Alright, and as I told you, this is not x, we suppose this is x, so once again we differentiate this 3x. So we write down into d dx of 3x. We write down into d dx of 3x. Into d dx of 3x. Fine. Formula you can write down. Formula we can write down here since d dx of sine inverse x is equal to 1 over root 1 minus x square. This is the formula. Alright. D dx of sine inverse x is equal to 1 upon 1 over root 1 minus x square. This is the formula, and the formula we are using. The only thing is in place of x I am writing 3x. X square, we have 3x, so 3x square. Fine. And this is equal to, this we can write down 1 over 1 minus, can I write down 9x square? Tell me. 3 square is 9 and x square, 9x square. And this, you know, 3 is a constant, and you know that the derivative of a constant is 0. But when the derivative of a constant is 0 when the constant is alone. Like d dx of 3 is 0. But here 3 is with a variable. So what we do, we keep the constant aside. We'll bring outside the effect of d dx. So 3 will be out. 3 will be out here. And then d dx of x, which is 1. I don't think I should write down that much because you are in 12th standard. So 3 out and d dx of x is 1. Is that fine? Should I write down? I am writing, but you need not write down. Huh? To make you understand, I am writing 3 into d dx of x into d dx of x. Alright. And d dx of x is 1, so next step will be 3 into 1 into 1. So that means 3 upon. Then you can write down 3 upon is equal to, can I write down here? So this we can write down then, is equal to 3 upon root 1 minus 9 x square. And this is the answer. This is dy upon dx. dy upon dx is equal to 3 upon root 1 minus x square. Clear? Fine. Finally, if you wish to write down, you can write down like this. Therefore, it's done. You can write down answer here. But if you want to put presentations, you can write down therefore dy upon dx is equal to 3 upon root 1 minus 9 x square. This is your answer, and this you can put in box. This is the answer. Dy upon dx is 3 over root 1 minus 9x square is the answer. Clear? Okay, fine. This is there's another method also, another approach. If you can call this as first method. If you understand this, fine. Otherwise, we can do this question like this also. So in that case, this will be method 1, and now you see method 2. Method 2. Approach 2. Can I rub now? This is the answer. You can write on your answer. This is the answer. This is the answer. Okay. Now see the second approach. Y is equal to as it is, and then I am rubbing this side. This is method 2, second method. Let y is equal to sine inverse 3x. Therefore, d dx of y is equal to d dx of sine inverse 3x. This we have to find out. Now, suppose 3x is equal to u is equal to 3x. Suppose let u is equal to 3x. We are supposing. Is that fine? So let u is equal to 3x. Alright, so in place of 3x we are supposing that 3x is equal to u. So then this will become how much? Therefore dy upon dx is equal to, therefore dy upon dx is equal to d dx of sine inverse u. Alright, 3x we are taking as u. Interesting and very easy. Now see, d dx, differential coefficient with respect to x of sine inverse u. The function is in u. You cannot differentiate with respect to x. Here it should be then u. If this is in u, it should be u. If the function is in x, then with respect to x. If the function is in z, then with respect to z. Fine. That means we should write down here d du of sine inverse u. So see how I'm adjusting. So this is equal to d du. I'm writing d du. Now you will say, why are you writing? How can we write down? So I am just telling you. d du of sine inverse u. And du upon dx. For understanding point of view, only for understanding point of view, if you cancel this du with this du, because this is in the numerator and this is in the denominator, so this du cancels this du, and you are left, ultimately we are left with d dx of sine inverse u, d dx of sine inverse u. Fine, see the adjustment. Though we cannot cancel that. Suppose du which is in the denominator cancels this du which is in the numerator, then we are left with d dx of sine inverse u, and we have d dx of sine inverse u. That means we can write down this like this. Now the question is, why are we doing that? We are doing this, you know why? Because now we are going to differentiate a function in u with respect to u. Sine inverse u with respect to u, sine inverse x with respect to x, sine inverse z with respect to z. Alright, it should be same. Alright, and d dx of u, that we will see in the next step. This is okay? Fine. This is called chain rule. Fine. So after this you can write down, this is equal to, can I rub now? Okay. Let me rub this. This is equal to the same formula, d dx of sine inverse x, 1 over root 1 minus x square. So 1 over root 1 minus u square here. So that is equal to 1 over root 1 minus u square. Alright. Like x square, d dx of sine inverse x is 1 over root 1 minus x square. Here it is u, so 1 minus u square. And this is d dx of u. So see how I am writing d dx. U, what is u? ddx of what is u? U is 3x. Isn't it? Clear? U is equal to 3x. Fine. We reach the same step. First method. This step is there in the first method. Remember, I told you, you take 3 outside and then ddx of x will be 1. So then after that, we can write down 1 over 1 minus u. U is 3. 3x, not 3. U is 3x. So in place of u, you can write down 3x. Write down then 3x whole square. And 3 outside, ddx of x. ddx of x. You can write down in bracket if you wish to write. Fine. These steps are there in the first method. Now ddx of x is 1, so 3 into 1 into 1. That means 3 upon root 1 minus this one. After this you can write down ddx of x is 1. So 1 into 3, that means 3, 3 1 are 3, so 3 upon root 1 minus 9x squared. Alright? Fine. And you got the same answer. Clear? If you wish to write down one more step, you can write down in place of ddx of x as 1. So you can write down 1 into 3 into 1, but that much you need not write down. You can write down 3. After that, you can write down 3 over root 1 minus 9x square, and this is the answer. Clear? Alright. Now, next question. Question number 2. This is called chain rule. Second question. Second question I am taking. Differentiate sine inverse root x with respect to x. Sine inverse root x. Alright. Sine inverse root x with respect to x. This is question number 2. So let y is equal to, directly I am writing, right? Y is equal to let y is equal to sine inverse root x. This is the question. Sine inverse root x. Fine. Sine inverse root x. Again, if you want to apply chain rule, you can suppose root x as u, then d du of sine inverse u into du upon dx, where u is equal to root x. If you want to do directly the first method, so therefore dy upon dx. Therefore dy upon dx is equal to how much? D dx of d dx of sine inverse root x. As you know the formula, d dx of sine inverse x is, d dx of sine inverse x is how much? 1 over root 1 minus x square, but in place of x we have root x square. Root x square. And this is not x, we are supposing this is x and applying the formula. So we once again differentiate this root x into d dx of root x into dx of root x. This you can put in bracket like this. First method. We are taking this, we consider this as x. This we consider as x, root x. We consider as x, and we are applying the formula sine inverse x 1 over root 1 minus x square, but x means root x, and since it is not x, it is root x, so we once again differentiate this root x, ddx of root x. Fine? Clear? And this is equal to 1 over root 1 minus x. This is root x square is x. Fine. And ddx of root x, directly you can write down 1 upon 2 root x if you understand. Otherwise you can apply the formula ddx of x raised to the power n. N is half. Alright, like this. ddx of this you can write down, ddx of root x you can write down is equal to this. This is not part of solution. I am just trying to make you understand how I am going to, because I am going to write down directly. I want to write down directly. This one you can write down your interest standard. So this you can write down ddx of root x as 1 upon 2 root x into 1 upon 1 over 2 root x. 1 over 2 root x. This one you can write down. ddx of root x is 1 upon 2 root x. Now I am explaining why 1 upon 2 root x. If you didn't understand, if you understood fine. If you didn't, then you please have a look. We can write down this ddx of root x as ddx of x raised to the power half, isn't it? So we can write down ddx of x raised to the power half. Fine. Same thing, no? Root x means x raised to the power half, and now we apply the formula of x raised to the power n, so which is n and x raised to the power n minus 1, half minus 1, half minus 1, and this is equal to 1 upon 2, and this will be x raised to the power minus half, and that comes down, so that we can write down then x raised to the power half. Is that fine? That much, so I can write down directly. Half minus 1 is minus half, x raised to the power minus half in the numerator, when it comes down in the denominator becomes plus half, and this is equal to 1 upon 2, x raised to the power half means root x. 1 upon 2 root x I have written. Understood? And then this is equal to 1 upon 2 is equal to 1 over 2, and inside the radical sign, can I write down like this, x and 1 minus x. Root x, root 1 minus x. Now I am writing x, 1 minus x. Fine. And then finally you can write down, therefore dy upon dx is equal to, therefore dy upon dx. Therefore dy upon, if you wish to write down, otherwise it's okay, you can write down here only answer. There only you can write down answer. Dy upon dx is equal to 1 over 2 root x 1 minus x. This is the answer. Dy upon dx is equal to 1 over 2 root x 1 minus x. Same thing, 2 root x 1 minus x. This is the answer, and this you can put in a box. This you can put in a box like this. This is the answer. Fine, this is first method. Second approach, as I told you, root x you can suppose as u. Please, you do practice. Practice is very important. Alright. The more you practice, the easier it is going to be. So you can do this on your own. You take as u is equal to root x, fine, and then you go ahead. You see the first question, the second method, where I am using chain rule. So I hope everything is very, very clear. If you like my lessons, please subscribe to my channel. Thanks for watching the lesson. Bye for now.